So to just show you an example of word problem, so let's get with a simple story. Let's see this, that Ram went to a shop to buy apples and oranges with $150. So if he purchases 20 oranges, he will have money left for 10 apples. If he purchases 10 oranges, he will have money left for 15 apples. How many apples can he buy with $150 if he does not buy oranges? Right, so that's what the question is asking for. So first and foremost, let's try to understand what is the required piece of information to answer this question. How many apples can he buy with $150 if he doesn't buy oranges? So Ram has $150, right? To find the number of apples that he can buy with $150, what is the information that I need to know to answer this question? I need to know the cost of one apple, right? Because if cost of one apple is $1, he can buy 150 apples. If cost of one apple is $2, he can buy 75. If cost of one apple is $10, he can buy only 15 apples. You know, the number of apples he buys, he purchases, and he can purchase depends on the cost of one apple, right? That's the point. So assuming that each apple costs the same and each orange costs something else, the same value for both. What I mean to say is cost of one apple is going to stay same and cost of one orange is going to stay same. So to answer this, I need to use the clues given in the earlier part of the question. So do I know cost of one orange? Because if I know that, I can actually answer cost of one apple with the clues given. But even I don't know this information, right? So cost of one orange, let me assume this to be O. And cost of one apple, let me assume that to be, this is $O and this is $A, right? So see this, if he purchases 20 oranges, he will have money left for 10 apples. That basically means Ram can buy 20 oranges and 10 apples with $150, right? So how much money would he have to spend for 20 oranges? One orange costs $0, right? If one orange costs $5, how much money would he spend for 20 oranges? It's basically 20 into 5, right? One orange is $5 for 20 oranges, it should be 20 into 5. So similarly, if I don't know the cost of one orange, it needs to be done like 20 into O plus, similarly for apples, 10 apples, so 10 into A is $150, because this is the money he would have spent on oranges and this is the money he would have spent on 10 apples. One orange cost O, 20 oranges will cost 20 into O, one apple will cost A or capital A, and 10 apples would cost 10 into A. So he spent money on these two only. So this sum has to be 150, right? Similarly, he purchases 10 oranges and 15 apples with 150, right? That's the other situation. So again, I can write equation like this: 10 into O plus 15 into A is equals to 150 is my another equation. So the basic rule is this in algebra: the number of variables should be equal to the number of equations you have. You know, in linear equation solving I'm talking about. If I have x, y, z as 3 variables, I need to have 3 different equations to solve and get independent unique triplet, or you know, unique value for each x, y and z. If I have, let's say, x and y and I only have one equation, right? That is like 10x plus, let's say this one, right? 20 oranges plus 10 apples is equals to 150. If I only have this equation, if I ask you what is cost of one orange, I will have multiple values for that. One apple could cost 0, so one orange will cost 7.5. One apple could cost 10, because of which one orange will cost only 2.5. You know, all of these are accepted. 20 into 7.5 plus 10 into 0 is 150. 20 into 2.5 plus 10 into 10 is 150. I can keep doing, I'll get infinite solutions for this. If I have two equations like this, and there are two variables O and A, I am bound to get, you know, one unique solution for O and A. There are cases where you won't, there are some cases where you will not get like this. There is a chance for getting infinite solutions despite having two equations or maybe no solutions. That is discussed in depth in algebra. You can watch those videos if you are interested to know that. So for these sort of word problems, the likelihood is almost zero. You'll get to see generally the number of equations given in such a way that you'll get a unique pair, a unique set of solution. The standard questions you see is two variables. So that's why you got to find two clues to write two equations, so that I can get two equations like this and solve both the variables and answer the question. Now, how to solve this, right? 20O plus 10A is equals to 150. 10O plus 15A is equals to 150. There are multiple ways to solve. One is, I use one equation to get O, one variable is equals to everything else, right? I send this to this side. It will be 150 minus 10A. 20 will go into the denominator, so it is 150 minus 10A by 20. Now I substitute O here in the second equation. 10 into the value of O is 150 minus 10A by 20 plus 15A is equals to 150, and I solve it, I'll get A and then I get O. This is one way, which is a bit tedious according to me. The other way is multiply equations with some constant number such that the coefficients of one of the variable is going to come as same. So if I multiply, this is 20O, if I multiply this with 2, what will I get? The second equation becomes 20O plus 30A is equals to 300. So 20O can be get cancelled, we can cancel by subtracting, right? So I subtract this equation from this, that is basically minus comes here, minus comes here and minus comes here. 20O minus 20O get cancelled out. 30A minus 10A will be 20A. 300 minus 150 is 150. So A is 7.5. If A is 7.5, now what will I do? I substitute back into one of these equations. Let me substitute here, right? 20O plus 10 into 7.5 equals to 150. So 10 into 7.5 75. So that will give me O as 75 by 20, that's 3.75. That's how I can solve, right? That's how you are supposed to solve a pair of linear equations. If you're not comfortable with this, make sure you check this, try this on your own and try solving couple of linear equations, because this is an integral part of solving word problems, right? So to put it in a very simple summary, what I feel is this, if you're already clear with solving word problems, you have a good experience or are comfortable, maybe you can skip this part of the video where we are going to revise what we have discussed now. So you should look for these three steps while you solve a word problem. First and foremost, define the required variables. Right? When I say define the required variables, I see students saying my variables are x and y, or alpha, beta, or maybe some love for some other language, you come up with something else. That's not what I mean by required variables being declared. It's not about taking some random letters as variables. That's not the challenging part. The challenging part is defining the variable properly. Let's assume that the cost of one orange is $0. Cost of the orange, one orange. I'm not saying, let's assume something is O. Cost of one orange is $0. Right? Sometimes I see students saying, I've assumed variable O. Okay, that's good. What is the meaning of the variable O? Variable O is O, or it's for orange. Okay, it is for orange, but for what? Is it for the number of oranges? Is it for the cost of orange, one orange, or is it for something else? Weight of the orange, height of the orange, color of the orange. You got to define that clearly, right? Unless you define it clearly in your mind. I'm not asking you to write it down on a paper. It's not a subjective exam where we do it. Back then in our schools we used to do it, or we were supposed to do it. But here the important thing is to have a clarity on what is being defined as this variable O or X or Y. It's not like orange is defined as O. No. Cost of one orange is defined as O. Similarly, cost of one apple is defined as A. That's the important part. Once I've done that, write the equations based on the statements, right? You'll have clues that will be given in the question, which should ideally give you the required number of equations, so that I solve them and in the step 3 and get the required answer. So like Ram can buy 20 oranges and 10 apples with $150. That should translate into 20 oranges plus 10 apples is $150. Similarly, Ram can buy 10 oranges and 15 apples with $150. That should give me 10 oranges plus 15 apples cost is $150. So I have two equations, two variables. technically I should be able to solve these equations, pair of linear equations, to get a unique solution. As I said, number of variables equals to the number of equations to get a unique solution set. So there could be a case where you might see a word problem where they'll only give you one clue like this, and if they ask you what is cost of one orange, you will have multiple values. As I said, you will have multiple values. Just make sure that you realize that. There's nothing wrong in that question. It's just that the answer for that question will be multiple correct answers. Maybe the question could be set in such a way that you have to mark multiple answers as correct. So maybe that suits for that. So just be careful on that part. That's it. But to get a unique pair, that is one value for O and one value for A, generally it will happen only if you have the number of variables equal to the number of equations. So you have two variables O and A, you are bound to see two equations. They will give you clues mostly like this so that you get those two equations. Then solve the following pair to find those values, like how you get for O so and so and A so and so, and then you will be done with the question. Or you might have to multiply or divide with something to get the required answer. Like in the earlier case, the question was asking how many apples can I buy, right? Only apples if I don't buy oranges. So $150, one apple is 7.5, so I can basically buy 20 apples if I don't buy any orange with $150. That's the answer you need to give. Let's look at this. Two bags can hold a total of 80 marbles. So I don't know, there are two bags, bag 1 and bag 2. They can hold 80 marbles together. The pink bag can hold 20 marbles more than the blue bag. So they have, let's assume this is pink bag and this is blue bag. They said pink bag, if I assume pink bag is P and blue bag is B, the number, okay, the variables. So what are these variables? Number of marbles in the bag. Right, so what am I saying? Pink bag has P marbles in it, blue bag has B marbles in it. So pink bag can hold 20 marbles more than blue bag. The pink bag, the number of marbles in pink bag is P, can hold, that's basically equal to 20 marbles more than blue bag. Whatever the blue bag holds plus 20 marbles, right? That's 20 more than blue. So blue plus 20. That's one equation. The two bags can hold a total of 80 marbles, right? That's what it says. So pink plus blue can hold 80 marbles. So how many marbles can the blue bag hold? Right? That's what the question is asking. So two variables, two equations. I just need to find out the blue bag B value so that I answer the number of marbles in the blue bag. So this is a bit more easier because P is given as B plus 20. So I'll substitute here, right? So P is B plus 20. So I write B plus 20 plus B equals to 80. So B plus B is 2B plus 20 is equals to 80. This goes this side, 80 minus 20 is 60 is 2 blue. So B is 30. That's the required thing, right? And P is, I will just find it out, 30 plus 20 is 50. So the number of marbles pink bag can hold is 50 and the number of marbles blue bag can hold is 30. So the sum is 30 plus 50, 80, and pink bag 50, right, is 20 more than 30. That's why both the statements are satisfied. That's how you solve this question. Two sprinters race times add to 230 seconds, and one of the race times is 30 seconds more than thrice the other. So one of the sprinters, it should have been one of the sprinters race times, race time is 30 seconds more than thrice the other. So let's assume time of sprinter 1 race is T1 and time of sprinter 2 is T2. Okay, these are two variables I am taking. It says that if we add them, we get 230 seconds. That is T1 plus T2 is 230 seconds. Clear? And one of the sprinters race time is 30 seconds more than thrice the other. This is the what you have to read clear again. So one of the sprinters time, I don't know which one it is. Let me assume that is T1. That's okay. Even I take T2 or T1, according to that we get those values. So that's okay. Is 30 seconds more than, so that is plus 30 seconds more than, this is thrice the other. So thrice the other is 3 into T2. If T1 is equals to, then the other is T2, right? Time taken by sprinter 1 is T1. That is equals to that is equal to 30 more than thrice the sprinter 2. So the time taken by sprinter 2, so that is 3 into T2. This is my second equation. Simple. So 3T2 plus 30 is my second equation. I just substituted this back into here. Or, there's obviously you can also do it like this. T2 comes here, it will become T1 minus 3T2 is equals to 30. That is my second equation. This is my first equation. So let me show it like this. T1 plus T2 is 230. T1 minus 3T2 is equals to 30. These are my two equations, right? So if I do it like this, minus T1 plus 3T2 and minus 30, because minus becomes plus, plus becomes minus, plus becomes minus. These two get cancelled out. T1, T2 plus 3T2 is 4T2, 230 minus 30 is 200, so T2 is 50. If T2 is 50, what is T1? Here, right, I see 230 minus 50 is 180, right, which I can also substitute here, right? So T1 is 3 into 50 plus 30, that is also 180. That's what the second equation is saying. So how much time did the slow sprinter take to complete the race? So slow sprinter is 50 seconds, right? Sorry, 180, because the slow sprinter would have taken longer time. So T2 took 50 seconds and T1 would have has taken 180 seconds. So who is the slower one? It's not this one, right? This is the one. Whoever took longer time is the slow sprinter. So that's why T1 took 180 seconds. That's the time taken by the slow sprinter to complete the race.